Bismillahirrahmanirrahim. Dear students, today we are going to discuss about the convolution. Okay, I have already uploaded a tutorial sheet with the name tutorial sheet 6, and if you find here, you are going to find two types of the question. One will be for the discrete time domain, the second one will be for the continuous time. So today we are going to discuss for the discrete time, and we will say that this is the convolution sum here. Okay, so the question is, we need to convolve the following sequences. Sequences means some function for the discrete time here. Okay, so this is the sequence to us here. This one and this one here. Okay, so we are given two sequences here, and we are interested in convolving them. So just before starting here, what exactly the convolution sum is. Okay, just quick discussion here, then I will start solving it. Okay, and I will solve using the two methods. One of them is using the formula, and I will be doing it in the graphical mode, basically, for the understanding of the convolution. And the second one, we will be doing basically the tabular one, which is very simple. Okay, you will get the answer very quickly. So let me start here. What we have basically, for example, in case of convolution, we say that this is the formula is y of n will be equal to the summation of, for example, some variable k is equal to from minus infinity up till infinity. We have h of k into x of n minus k here. This is basically equivalent to if I change the order here. K is equal to minus infinity to infinity, x of k into h of n minus k here. Now what it mean? It means that basically I need to take any signal, anyone, okay? Either I can take x or h here. It can be any of the signal here, okay? So one of the signal we are going to try to keep it constant here without changing anything here. This is x of k in this case. In this case, it is h of k. Okay, so one of them we can keep without changing here. The second signal, what we will do, we will take it and we are going to flip it. Okay, if you see here, everything is in terms of k here. So basically my variable is x of minus k here, or in this case it is h of minus k. Means I need to flip this signal and then I need to shift over the other constant signal here. Okay, so it means that in case of convolution, one of the signal will be flipped and move over the other signal here. Now, which signal to flip and which signal to move on, it doesn't matter. Okay, you can take any one signal, make one of them signal flip and move over the other signal. So normally what we do, we try to keep a bit complex signal constant without flipping, and the other signal, which is some comparatively easier, we can flip it and we can move it over the other signal here. Okay, but if you do the other way, you will end up with the same answer, and like the solution will be perfectly all right here. Okay, so what are the steps basically here? So the steps, I mean, I'm just writing the general steps here. What we can have, the steps which we can follow for the convolution is, the first one is we need to flip the signal here. I'm just writing flip the sequence here. Okay, which sequence you are flipping, it depends. Either you can flip h or x here. If I assume this one, for example, so basically I'm flipping x here. Okay, so I'm just flipping it x of minus k here in this case. But it can be anything. It does not mean it is x. It can be h also here. Okay, so one of them will be flipped here. Secondly, we are going to perform the shifting here. Okay, how we will perform the shifting? Shifting will be, for example, we will say that h of, sorry, okay, h of k. So in this case, it is x basically. I will say x of, I already flipped it, so x of minus k, I already have plus n here. Okay, it can be the value of n can be positive or negative depending upon from where you start here. Okay, so I'm just writing it as plus k plus n here, which is nothing but basically x of n minus k, what you have here basically. Okay, so you will shift it. The third one will be basically you need to perform the multiplication here, multiply here. What you are performing here, we are multiplying h of k with x of n minus k here. And the fourth one will be you are going to perform the addition here. Okay, so addition means summation of this whole term here, basically summation of this one. Okay, so this is the whole process. And what we will do here, we are going to repeat. We are going to repeat this from 2 to 4 here again. We will do one time. We calculate the addition, then we will repeat, like we will perform the shifting again, we will multiply, add again, and again we will perform the shifting and we will multiply and add, and so on, unless we reach or unless we move the flipped signal over the other signal completely here. Okay, this is the whole steps or whole scenario I will be following. Okay, if I need to do it in the graphical way here. Yeah, this is what I'm going here, so I'm just removing this one right now. Okay, now let us start. Okay, but just before here, let me plot here. Okay, let what I do. My x of n. How is x of n here? X of n means, sorry, x of n means I have a sample. Let me make it with this one, maybe bigger or maybe red one here. I have a sample. This is 1. Then I have 2. Then I have 3. Then I have 4 here. Okay, so this is your x of n here, and this is your n here. Okay, this will be 1, 2, 3, and 4 here. And the rest of the values here are zeros here. Okay, make it 1 here. Similarly, h of n will be here. H of n will be h of n is basically 0. Then we have 2, and 2, and 2 here. So 1, 2, 3 here. This is your n here. This is your h of n here. So this is 2, 2, and 2 here. Okay, so this is basically your x of n and h of n here. Now, what is the formula? The formula is basically y of n equal to summation. I told you one signal we will keep fixed, one we will remove. So let's suppose this signal is completely comparingly this signal. This is fixed. So I will try to keep this one fixed here. Okay, but if you do the other way, it doesn't matter. You will get the answer, same answer here. Inshallah. Okay. Let's suppose I just keep it fixed. So it means I will say that this is x of n, and the other one I will flip and shift here, n minus k here, and the value of k will be k is equal to minus infinity to infinity. Again, this is not minus infinity to infinity. It will have some values here. Okay, this is the general. One more thing I forgot here. He said that convolve the following signal. So basically, I want to find y of n is equal to x of n, and this is your convolution symbol here. Okay, into h of n here, which is basically equal to this formulas here. Okay, so now what we need to do here, first of all, we are going to flip the signal here. So I'm going to flip this signal here. So when I flip this signal, the signal will become something like this here. Means this will be at 0, it will be 0. This will become 2 minus 1. This will be 2 minus 2 here, and this will be 2. This is minus 3 here. Okay, and I will call it like this is just I will be back. Okay, after the salah. Just 1 minute, please. Okay. What we have basically, we say that, sorry, I just make it wrong. The formula is y of n is equal to summation k equal to minus infinity to infinity. This will be k, not n. Okay, previously I write n here, so please correct here. Okay, and this will be n minus k here. Okay, so the first step will be, I need to rewrite this x of n and h of n in terms of k here. Okay, so how we will write it? It is quite simple. Just what we will do, we will change the index here. So I will say that instead of this one, this is x of k here. Same thing here. And my index from n, it will become k here. Same here, this will be h of k. This will be k here. So overall, the picture is same. The only label of n is changed here. So from n, it become k here. Okay, just to transform it in this form here. Clear? Next thing is, basically, we are going to perform the flipping operation here. So flipping means the flip will be basically the signal will be basically this will be 0, this will be minus, this will be at -1 and -2 and -3 here. Okay, this is 2 2 2 here. Okay, and we will call this one as h of minus k here. Basically, we have flipped, we have performed the, we have flipped the signal here. Okay, here in this case. Now what we will do here, basically, I will take the whole signal, I will take this signal and I will move over this signal here. Okay, so now from which point should I start here? From which point should I start? It's simple here. I need to start from the place where I will have first non-zero value here. So basically, I need to start this signal from here. Okay, now, right now the value here is n equal to 0. So at n equal to 0, this is the situation I have here. And obviously 0 is here is 0. When I put it here, so it will make everything 0 here. Let me show you here. At n equal to 0 here. Let's suppose I'm assuming the value of n, I'm assuming for n equal to 0. So what I will have basically at n equal to 0, let me plot here the signal. Let me make it down here. N equal to 0. Okay, this is my signal. I'm just making the signal again here. Okay, so basically this is my signal here. This is your 0. This is 1. This is 2. And this is 3 here. Okay, and this is your k here. This is your x of k here. At n equal to 0, I'm just talking about this one. Okay, what will happen? This will be the situation with me here. This is k here. This is h of n 0. So 0, if I put 0 here, okay, if I put 0 here, this will be, let me write 0 minus k here. So what will happen? This is 0. This is 2. This is 2. This is 2 here. Now, if I multiply these two signals, if I multiply these two signals here, if I multiply these two signals here, it's quite simple here. This all values are 0 here. So 0 multiplied by this thing will give me 0 here. Okay. Similarly, all these values are 0 here. So all this value, when I multiply with this signal, will give me 0 here. Okay. Again, make a small mistake, but please point my mistakes here. It's like at 0 I have 1. At 1 I have 2. At 2 I have 3. At 3 I have 4 here. Okay. But still y of 0. Like if I put the value of n as 0 here, it will be equal to summation for the value of k. Let's suppose I say that k equal to 0 to 4. I have x of 0 or x of k into h of n minus k here. Okay, so in this case n is 0, so 0 minus k. Obviously I will get 0 here. Okay, it's quite clear here. Now what we will do here, we will shift to the right by 1 here. So shift to the right by 1 means the value of n will be 1 here. Okay, if we shift to the left by 1, the value of n will be minus 1 here. So in this case, what we have basically, I'm just plotting the h of n minus k here. Okay, so what will happen? For example, this is h of 1 minus k. In h of 1 minus k, basically, what we are going to have, this will be shifted to the right here. Okay, this 1, 0 will shift to the 1. This sample at minus 1 will shift to 0 here. Okay, and sample at minus 2 will shift to minus 1 here, and sample at minus 3 will shift to the basically minus 2 here. Now if we multiply here, so y of 1, I'm just not writing the summation here, y of 1 will be, if you see here basically, now if you multiply them, what we will have basically, I'm just multiplying this signal with this one here. These two signals I'm multiplying here. Now if you see here, all these values are 0. 0 multiplied by these two samples will be 0 here. Because I'm just writing 0 here. 0 plus. Next what we have, this is 2. 2 multiplied by 1 will be equal to 2 plus. This all values are 0. 0 multiplied by all these values will be 0 again here. So this will give me 2 here. Okay. If you want, like I did not write it, but you can say, okay, this is like some summation in terms of the k here. This will be x of k into h of 1 minus k here, and I got 2 here in this case. Okay, so I will continue this process unless I move the shifted signal over the other signal completely here. So I need to take the signal here, how I will take it basically. Okay. Just I just bring it here so that I can have a space here. Okay. So what we have now basically, we finished with n0 and 2. What we will do basically here, we will basically say n equal to, we will say basically n equal to 2. So for n equal to 2, what we will have? Now, this will be further shifted to the right, okay? So the signal, what we have basically is, this will be your k. And if I shift this signal to the right, you can see here, this sample will be shifted to 1 here. Basically, at 1 I will have 2, at 0 I will have 2, and at -1 I will have 2 here. So if I need to multiply them, y of 2 will be equal to, it will be just simple. Okay, now what we have, basically just take the signal, this sample at 1, 0, this multiply by all the values of 0 here, so it will give me 0, plus at 1 I have 2, at 1 I have 2 here, multiply by, at 0 it is 1, so it will be 2, plus at 1 again I have 2, 2 multiplied by 2 will give me 4 here, so it means it will become 6 here. Okay, and we are going to repeat unless we move the other signal over the other signal completely here. Okay, so n equal to 3. Now we will shift this one further here, so you can see here the signal will become at 1 and 2. So the signal at 1 will come to 2 here, signal at 0 will come to 1, and signal at -1 will come to 0 here. Okay, now if we are going to multiply it, so y of 3 will be equal to, basically, this is 2 multiplied by 1, to show you again, this one multiplied by this one, so 2 multiplied by 1, and basically plus at 1, this is 2 multiplied by 2, it will become 4, plus at 2 it is 2, so 2 multiplied by 3 will become 6 here. Okay, so if you add them, you are going to get basically 12 here. Okay, next will be n equal to 4. So for n equal to 4, what we have, we will shift it to the right by 1 again, and now what we will have, we are going to have this situation here. In the sample from 0 will come to 1, the sample from 1 will come to 2, the sample from 2 will come to 3 here. Just multiply it with your original x of k signal, and you are going to get the y of n here. Okay, so obviously n here is 4, so I will say for y of 4 it will be equal to, at 1 this is 2, at 1 it is 2 here. So okay, like here this is 2, this is 2 here. 2 multiplied by 2 will be 4, plus, and 2 multiplied by 3 will be 6, plus, and 2 multiplied by 4 will be 8 here. Okay, so 8 plus 6 plus 4 will become 18 here. Here, next one will be, I need to shift further, because I mean my signal here is still 3 here, and I will be continue unless I completely pass over this 3 here. So n equal to 5. For n equal to 5, what we have, basically, signal from 1 will be shifted to 2, so it means it will start from 2, and the signal at 2 will be shifted to 3, and the signal from 3 will be shifted to 4 here. Okay, with the same amplitude here. Now if you multiply here, so y of 5 will be equal to, basically, at 2 the sample and here is 3, so 3 multiplied by 2 will give me 6, plus at 3 the sample is 2 and the sample in the x is 4, so 4 multiplied by 2 will be 8 here, and in case of 4, obviously this is 0 here, so 0 multiplied by 2 will be equal to 0 here, so I will have 14 here. Okay, now we will shift it further here, so n equal to 6 means the sample from 2 will move to 3, sample from 3 will move to 4 here, the sample from 4 will move to 5 here. Okay, so basically, like, this is the 3, 4 and 5. We need to multiply here, so y of 6 will be equal to, at 3 the sample here is 2, at 3 the sample here is 4, so 2 multiplied by 4 will be 8, plus the remaining samples here are 0 here, so 0 multiplied by anything will give me 0 here, so I will get 8 here. Okay, now if you see here, my first sample here is at 3, my last sample here is at 3, is next time when I shift it further, m will be going out here. There will be no multiplication possible here. Like for example, at n equal to 7, what we can have basically, a sample will start from 4, 5, and 6 here. Okay, so obviously the sample here from 4, 5, or 6 here is 0. So 0 multiplied by all these samples will give you 0 here. So y of n such that the value of n, or you can say like, let me here, n greater than equal to 7. It will always end up in giving me 0 here. Okay. Similarly, if we go here, let me know. Maybe I can say here, for example, for y of n such that the value of n is less than 0 or less than equal to -1. Okay, so I'm just writing less than 0. It will be again 0 here again. Okay, so basically what happened, we were able to find y of n here. So let me write it in the sequence form. So I can say y of n will be equal to my first value at 0. My first value at 0 is basically 0, then 2. Okay, it will be basically 0. Then we have 2 here. Then at 3, the sample is 6. Then we have 12. Then we have 18. Then we have 14. Then we have 8. And obviously it will be 0 again here. Okay. So basically, if you see here, like the sample here is at 0, 0. Then we have 2. Then we have 6, 12, 18, 14, and 8 here. And again, it is 0. And obviously at 0, it is 0 here. Okay. So I can put a marker here. Clear? So now it is very easy for you to plot here. So you can just simply plot it. Okay, y of n here. Let's suppose y of n here is, I'm making, at 0 it is 0, for example. At 1 it is 2. At 2 it is, for example, 6 here. 2, 6. Then I have 12 here. Let's suppose this is 12 here. Maybe let me make it smaller here. Okay, I think it's very big here. At 1 it is 2. Then maybe this is 6 here. Okay, just roughly. Then we have 12 here, just a double of it. Let's suppose this is 12 here. Then we have 18 here. Then we have 14 here. 14 will be obviously greater than 12. Then we will have 8 here, for example, greater than here. And this is 1, 2, 3, 4, 5, 6 here. And this is your n here. And this is your y of here. Clear? So this is how we are going to calculate y of n here. Again, the method is quite straightforward. What we did basically, let me quickly repeat here. Okay, like we were given the signal which was x of n and h of n here. Okay, so the first thing is we just plotted the signal x of n, which was like this in the red, and x of n like this. Now we know that we need to convolve it. So this was your convolution operator here. So x of n convolve with h of n. And when you write it in the summation form, we need to write x of k or h of k. Okay, one of them can be here. In our case, I say that we are going to fix this signal, means we are not flipping the signal. So that's why I'm writing x of k here. In case, if you say that, okay, let me flip this signal, x of k, h of k, you can say that, let me keep this one constant. So you can say this is h of k into x of n minus k here. So what we do basically, the first thing is, if you see here, my the variable he used here is basically k here for the index here. Okay, so what we do here, we basically convert from n into k here. So it's simple. Instead of n, we will write k here, like what I write in the green here. Okay, instead of n, I just write it in the k. So this is converted or transformed to x of k here. The next step is I need to flip the signal here. Okay, so how we are going to flip it? Flipping it quite simple. So we will flip the signal.
I need your consent on a few items to continue.
So what we will do here basically, we will say, okay, this is when you flip it, this will be -1, -2, -3 here, and obviously the amplitude will remain same here. So I flipped my h of k as h of -k here. Okay, now what we will do here, we will take this signal and we will start from the beginning of the other signal and move it in the step by step here by shifting it. Okay, if we put them one over each other, like for example here, without shifting anything here, the flipped signal with this signal, and this is at n equal to 0. You can see here there is no swap between the two here. This is 0, so 0 multiply by all these values, like all these values here is 0. So this 0 multiply by anything will give me 0 here. Similarly, this values on the negative side is 0, multiply by all these value will give me 0. So 0 multiply by 0, and sum them, you will get 0 here directly. Okay, basically it will start when I have some overlapping between the two samples here. Now what we will do, we will take the signal and we will shift it to the right by 1 here. Okay, so when you will shift it to the right by 1 here, it will become n equal to -1. So this sample will shift to 0, this sample will shift to -1, this sample will shift to 2 here. And now we are going to multiply these two signals here, my x with h here. Obviously at 0 I have the samples multiplied with each other. So 1 multiplied by 2 plus all these values 0 multiplied by this one will be 0, and all these values multiply by 0 will give me 0. So basically when we multiply and add them, because this is the operation we are performing multiply and then we are doing the summation here. So this will give me 2 here. Now I need to shift it further. Basically I will move this signal over this signal completely here. Okay, when you shift it further, it will become n equal to 2 here. Okay, here. So basically this sample will come at 1, this sample will come at 0, and this sample will come at -1 here. It will multiply with each other. Now you can see here, this sample before 0 multiply by this one will be 0. Then at 0, this is 1. So 1 multiplied by 2 is 1 multiplied by 2 is 2. Similarly, at 1, it will be 2. 2 multiplied by 2 will give me 4 here. Basically, it will be 6 here. Okay, just quickly again, the sample what I have here, I mean, I'm just only talking about this one. We have 1, we have 2, we have 3, we have 4. This is your X signal. Okay, my H was currently, it is basically at 1, it is 2. At 2, it is 2 here. So this 2, this is 1. So this 1 multiplied by 2 is 2. This 2 multiplied by 2 will be 4 here. And I have another sample here. So this multiplied by 0 will be 0 here. Okay, so just simply add them, you will get 6 here. Next time we will shift it again here. So when you shift it again here, what you will have, this sample will come to 2, this sample will go to 1, this sample will go to 0 here. So we will take these values. Now we will multiply with x here. So obviously at 0, this is 2. So 2 multiplied by 1 is 2. And at 1, this is 2. At 1, this is 2. So 2 multiplied by 2 will be 4. And at 2, this is 2. So 2 multiplied by 3 will be 6 here. So just add them, you will get 12 here. We shift again. Now at 1, I have 2. So 2 multiplied by at 1, I have 2. So 2 multiplied by 2, 4. And the next 2 multiplied by 3, 6. Then the next 2 multiplied by 4 will be 8. So add them, you get 18. Similarly, just we move on and we multiply and add, we got these values here. Okay, and obviously, after I pass from 3, means I start my H as 4 here. So obviously, every value will be 0 again here. Okay, so that's why this is the values I got here. And when I plot it, I got this signal here. Okay, so this is your y of n, which was the required solution here. Okay, just small discussions I need to make here. Like quickly, should I do it here or just do it here for the same question? Okay, for the same question, let's suppose I'm just writing x here. I'm just writing my signal x here. So x is basically like we have 1, then we have 2, then we have 3, then we have 4 here. 1, 2, 3 here, and this is your x of n here. And my h was basically, without flipping, it was basically, if I'm not wrong, it was 0. Then we had 2, then we have 2, and then we have 2 here. So basically this will be 1, 2, 3 here, and this is your h of n here. Okay, now for my solution, y of n, what will be my starting value of n here? Like what is the index here? Okay, for which is starting here for my solution. So you can find it from here, simple. What is the starting value of x of n here? The index is 0 plus. What is the starting index for h here? This is 1 here. So for the starting index for y of n will be 1 here, which is here. I mean, this is 0 here. Obviously, we don't count 0 here. So you can see this is 1 here. Clear? The first thing. Second thing is, what is the end index here? How we get 6 here? Obviously, we did it graphically, we got 6 here. After 6, it will be 0 here. It's quite simple. We will have the end index of x plus the end index of y, which is 3 again. This is equal to 6. So that's why we have up to 6 here. Okay. The next thing is basically we got the, okay, how many number of samples, how we are going to have the number of samples in y of n here. So the number of samples in y of n will be the number of samples in x plus the number of samples in y minus 1 here. You can have, for example, the number of samples in x are, how many samples we have? 1, 2, 3, 4 here. So the number of samples in x are 4 here. Let's suppose I said that this is the length of x here. I just give it some name here, okay? The number of samples in h, let's suppose this is 3 in this case. Okay, obviously 0, we are not counting 0 here, okay? This is only just to show you the index, like this is starting from n equal to 0. The number of samples in y will be equal to the number of samples in x plus the number of samples in h minus 1 here. It will be 4 plus 3 minus 1, which will be equal to 6 here. You can see here, I have 6 samples here. This is your 1, 2, 3, 4, 5, 6 here, okay? This is only to show you like this is starting at n equal to 0, and this will be my index at n equal to 1 here. So the number of samples in y of n is 6 here. Okay, so this is like quickly you can find how many samples, what is the starting index and the end index for your y of n here. Again, what I'm telling you is only I mean applicable to the discrete time signals here, not for the continuous time. Okay, brother, is that okay? Any question about it? Anyone attend? Yeah, Mazir. Any question, brother Mazir and Abdullah? Any question about what I did right now? No. Okay, so this was like the graphical method. Maybe in the lecture you have used the formula to solve it. Okay, so just giving you a graphical understanding that how we solve it. Okay, this is one method here. I will solve the same question with another method here. Okay, so for the same method, I'm just doing it. It's very easy. Second method is very easy here. Okay, so let me just copy the signal here. Yes, question. I'm just solving it using another method here, and very easy method. You will get an answer very quickly. Okay, this will be the tabular method here. Now let's suppose my x of n is this one. Okay, just I'm rewriting it. So x of n is basically like we have 1, 2, 3, and 4 here. Okay, this and I said that this is my marker at 0 here. Let's suppose I give it an index here. Okay, you can say like this is x of 0, like x of 0 here. I'm just writing it as x0 here. Okay, I mean it's only just the abbreviation here. Just for simplicity, it means this will be like, for example, x0. This is your x1. This is your x2. This is your x3. I mean, I'm just calling this particular value as this thing here. Similarly, my h of n is equal to 0. And we have 2, 2, and 2 here. Let's suppose this is your h of 0, same as like what I use here. This is h of 1 here, this is h of 2 here, this is h of 3 here. Okay, if you want, you can still write it in this form, x of 0, x of 1, x of 2 or something. Okay, up to you, doesn't matter. Now what we will do here, we are going to make a table here. We are going to make a table here. On one side, you will write x. On the other side, you will write h here. For example, it's up to you, okay, whichever you write here, doesn't matter, okay. If you write x here, which is a bigger signal, you can write the smaller here, then obviously your solution will be expanded. Otherwise, if you write it in the other way, it will go down, okay. It doesn't matter, you can write anyone here. I'm just writing x here. Let's suppose I say that this is x0 is equal to 1, the value, x1 is equal to 2, x2 equal to 3, and x3 equal to 4. Okay, again, you can write it in this form, no problem here. Okay, better I think if you write like this. Similarly, I'm just writing h on the other side. So h of 0 here equal to 0, h of 1 will be equal to 2, h of 2 will be equal to 2, and h of 3 will be equal to 2 here. Okay, and no, we already know that convolution sum is basically the multiplication and addition operation here. Okay, so first what we will do here, we will do the multiplication operation here. How you will multiply? You will take this value, you will take this value, you will take this value, and you will multiply with each of them and record them here. Okay, so what we have right now basically 0 multiplied by 0 multiplied by this one will be give me 0 here. So 0 multiplied by anything is 0 here, simple. 0 multiplied by 2 is 0, 0 multiplied by 3 is 0, 0 multiplied by 4 is 0 here. Okay, the next one is you will take 2 here. So 2 multiplied by 1 is 2, 2 multiplied by 2 is 2, multiplied by 2 is 4, 2 multiplied by 3 is 6, and 2 multiplied by 4 is 8 here. Similarly, I will take this one and multiply here. So 2 multiplied by 1 is 2, 2 multiplied by 2 is 4, 2 multiplied by 3 is 6, 2 multiplied by 4 is 8 here. Okay, so I will get 2, 4, 6, 8 here. Just I'm writing here. Okay, so take this value, multiply with each one here. So I am able to write them here. Next thing here, the important thing here. Okay, you need to mark them, you need to circle them, whatever you want. Let's suppose I just circle them. The value at n equal to 0. In this case, this is the value at n equal to 0. So I need to mark them. Okay, I just put it circled. If you want, you just simply mark them like this. Okay, up to you how you just like this only for understanding it. Similarly, for the other signal, this is the value at n equal to 0. So I'm just marking the signal's value here. When we multiply this value, the marked value with another mark here, I'm going to get some value here. Okay, it can be any position. In this case, this is the position. I need to mark that position also here. So I'm just marking this position also. So I'm just marking this one here because this will help me that from where it will start here. Okay, this is first thing. Second thing is now we need to do the addition here. Okay, we finish with the multiplication here. So what we will do here, we are going to add in uh, the diagonal like this here, basically the values. So it's now the solution is ready here, simple. So we have y of n will be equal to, start with the first one. So this is only 0 here. This is only 0 here in this case. Okay, so I just write 0 here. Next one will be, add these two here. So 2 plus 0 will be equal to 2. Then add all these values here. 2 plus 4 plus 0 will be equal to 6. Okay, I mean, don't put the arrows here. Please don't confuse. I'm just putting the arrows. You understand here. 0, this will be 2 here. Then this will be 2 means this is here. Okay, 2 plus 0 here. Next one is 2 plus 4 plus 0. This will be equal to 6 here. Okay, so I'm just writing here 6. Next one is 2 plus 4 plus 6. This is basically 10 plus 2, 12 here. Okay, so just we write that 12 here. This will be equal to 12. Next one will be 4 plus 2 plus 8. So this will be equal to 14. I'm not wrong. No, 6 plus 18 here basically. Okay. Then 6 plus 8 will be equal to 14 and it will be 8 here. Okay. Now we were able to get the same answer like what we did previously in the other method. Now we need to decide which particular value it at n equal to 0. So now we already make a marker here with the green. I did it here. Okay. So I know that this is my marker here. This will be my value at n equal to 0. This is your solution. Okay. So I mean, there are many methods. I mean, normally different tabular form you will find. Okay. I think it's basically Wozni here, if I'm not wrong here. This is the Wozni method. Okay. But I'm not quite sure, but I think it's like this. Clear, brothers? Any question about this solution here? Any question about this solution? No. Just one last comment here. Okay, for example, okay, for example, okay, let me make it here, change here. For example, in my question, my arrow is, I'm just doing it with red, okay, let's suppose my arrow is here. Similarly, in this case, for example, my arrow is, okay, so I'm just putting the change with the red marker here, okay. It means this is the value at n equal to 0. So obviously, you will do the multiplication as it is, no problem. But you need to mark. So it means this value is at n equal to 0. And for this one, this is the value at n equal to 0. When you multiply, 2 multiplied by 3 is 6. So it means this is the value at n equal to 0 here. Clear? So once I get the multiplication and then I solve addition, basically I'm going to get the sequence here. Now, which value is at n equal to 0? Simple. When you add here, 6 plus 4 plus 2 is 12. It means when you add this one, I have this circle here. So it means this is the value at n equal to 0. Clear? So that's why we put the marker. So we know that in the sequence y of n, which value is at n equal to 0. Okay, so this is like the method to solve it. Okay, so rest of them, I mean, I give you multiple examples. Please go through the example, and if you have the question, please you can discuss with me. Okay, any question about this one, yeah, Mazen? Any question, brother? Okay, so thank you so much. This is what I needed to tell you. Please go through the questions, and if you have any doubt, any problem, you can discuss with me. Okay, welcome, brother. Okay. Thank you. Assalamu alaikum. We can leave now, okay? So I can close the session. Assalamu alaikum.